right, this is problem number 7. We're being asked to find the integral of e raised to the x over e raised to the power of 2x plus 2e raised to x plus 1, all multiplied by dx. So I began by factoring the denominator to get e to the x plus 1, all of that squared. Let's kind of check my work, just some basic college algebra. You just have to be careful with that e to the x, making sure that it is e to the 2x when you multiply those out. Kind of verifying that e to the 2x plus 2e raised to the x plus 1 does in fact match our original denominator. So continuing on from this factored form, working with the denominator, we did a little u substitution. So I set my u value to e raised to the power of x plus 1. Taking the derivative of that produced e raised to the x dx. And you can kind of see the factored form here. Setting that dx value equal to, or the du equal to ex dx. Continuing on, taking that denominator and setting that inside value of the parentheses to our u value, kind of cleans it up into a more usable form, and then taking the ex to the dx to our du, so we're just simplifying, a little easier form to work with. Taking that 1 over u squared and just rewriting that as a negative exponent to allow me to kind of better see how to add our unit 1 and then multiply by the exponent. So we did u to the negative first, all being divided by negative 1. So make sure that negative carries over. So then we have negative 1 over u. We can go back and substitute our original value of u, which was e to the x plus 1. Plug that back in, and then very important, don't forget your constant integration. Notorious for forgetting that. So just kind of sum it all back up. We have our original formula, e raised to the x all over e to 2x plus 2e raised to the x plus 1 dx does in fact come out to negative 1 over e raised to the x plus 1 plus c.